What's up, everybody? This is Matt Brown with another IoT hacking video. Today, we're taking a look at a mobile app called RedNote. This app has been in the news recently because of the looming United States TikTok ban. A lot of people are jumping ship to another Chinese social media app, and other people have raised concerns about the privacy policy and security issues that are potentially in this app. Well, in this video, we're not going to talk about theory. We're going to demonstrate multiple real security vulnerabilities that I've discovered with just a couple hours of research in this mobile app. So before we jump into it, who am I? I'm Matt Brown. If you're new to this channel, what we do is we're usually taking apart like hardware devices over here on the workbench and figuring out what the software does on those systems. But in that work on IoT devices, I also take apart and analyze a lot of mobile apps, and that's because those IoT devices usually need some mobile app to control them. But in this video, we're going to be primarily and only focusing on this mobile app. And so let's jump into that and see what we can find. So as we said, this is called RedNote, or the company's name, kind of translates into, Little Red Book, Xiaohong Shu. If your Mandarin is better than mine, which I bet it is, you can correct me on my pronunciation of those tones in the comments. So what I did, I've got a factory reset phone. I haven't even put my Google account on this phone. And I've gone ahead from a site called APK Pure, gone ahead and downloaded the app, because then you don't need to have a Play Store account in order to get the app. So I've got the latest version of the RedNote application, and I have installed it to my phone here. And we're going to see on screen that this is a physical phone, but you can see that it's mirrored on the screen for you guys to see. And so the first thing I want to talk about is our first goal is to figure out where this app is communicating with out in the world. What servers, what IP addresses, things like that. And so what I'm going to do to set the stage is I'm going to use a tool that I've developed myself. Calling it a tool is kind of an overstatement. It's really just a script that pulls together different open source Linux tools to do something cool. So in this diagram, over on the left side, we see IoT device. Well, we're just going to replace that with, that's our mobile phone. That's the device that we're testing, the application we're testing today. And then that is connected to a Wi-Fi interface that's running on host APD. That's connected to my Linux machine, and then that's all feeding into this BR0, or the Bro interface. And then we have, you have a DHCP server to hand, my phone and IP address and stuff like that. And then optionally, we're not going to do this at first. First, we're just going to passively observe packets as they go from my phone out to the internets. But then the next step we're going to do is we're going to activate some of these IP tables rules to conduct a man-in-the-middle attack, where we're going to try to attack the trust relationship that the app has with certain web servers that use TLS to encrypt that traffic, and see if we can do an attack on that communications. So with that, we are going to jump into the application here. So you can see here, I've got down here at the bottom, I have the RedNote application installed on my device, and then we are going to come over here and look at Wireshark. And I'm actually going to completely wipe the slate clean here in Wireshark, and we will clear out my filter, and then I'm going to open the application. So now I've opened the application. You can see some stuff loading in, and we see a ton of traffic flowing by in Wireshark. Well, if you know anything about Wireshark, you're probably seeing the color coding of the default settings in Wireshark, and you already know that something really bad is happening. But we're going to ignore that for just a little bit, and we're going to filter down to just DNS packets. And we're seeing a ton of stuff fly by for DNS here. And we see a lot of server names here that are being requested, because if we don't know, DNS, its job is to resolve a domain name to an IP address, or in some cases vice versa. But most of the time, DNS's job is to take a human readable name like FPIT, fengkongcloud.com, and translate it into its actual IP address. Well, let's go ahead and clearly we're not seeing some of the responses one after another here, but let's just go ahead and let's copy the value of this domain name, and then we're going to go pop over here and we're just going to run ping in order to resolve that IP address. And then we're going to use the whois tool to get the record of what entity owns this IP address. And we are going to see that this is located in China. This is run by Tencent, which is kind of like the Amazon Web Services of China, right? They do a lot of cloud computing, other IT services and stuff like that. So we can see that very clearly this device, this application is communicating out to servers in China where the United States probably doesn't have jurisdiction, right? So that's maybe concerning, but okay, there's lots of servers. It's a global internet. Yeah. Let's dig in a little bit more here. So we could definitely go through more of these. I do believe in my brief analysis that all of these subdomains off of this domain here, I believe I've seen some other ones, yeah, like this one, they are all hosted in China, and then some of these other servers like, you know, ZZT Fly, I think these are they're not hosted in China. They might be hosted in Singapore. Let's go ahead and look at one more of these. It's not all the data is going to China, but definitely some of it is. So let's just ping that host for a second. It didn't resolve. Here it is. Let's run whois on that IP address. And, oh, no, this one is hosted in China too. All right, so we got a whole bunch of stuff hosted in China. These cloud servers that this app is sending all its data to is located there. There's definitely some stuff not in China. I just picked two random ones that I thought would be different. So let's now move on to some more analysis of this PCAP. So like I hinted at, when I take this filter off, there's something that's really wrong, and that's because this green in Wireshark is the default color scheme for clear text HTTP, right? This is not encrypted web traffic like HTTPS, right? We see port 80 stuff going on. So then we can apply the filter HTTP, and this is going to give us a ton of content that is flying over the public internet in clear text, unencrypted. And what kind of content do we have? Well, if we scroll through this, we see, you know, some stream data, so probably the video streams from the application, you know, something about a video, we see a JPEG image. Okay, so let's actually try to grab this data out of Wireshark. So what we can do in Wireshark when we see something like this, we can actually click down here on the reassembled, you know, the whole like TCP message getting reassembled between multiple packets, and then it is actually identifying a JPEG image type here, which is pretty cool. So what we can do actually on this thing here we can see that in the hex view down here, it's actually selecting that whole image file. So we can actually go right click, we can say export packet bytes, and then we can actually save this. So as, you know, let's call it image.jpg because that's its file type. And then we'll go ahead and come over here back to our terminal. And now we see that we've saved that out here. We can like go ahead and look at that in a hex editor to make sure that it looks good. Okay, that looks good. We're gonna run the file command on it. Looks like it's gonna be a JPEG. Let's see. All right, if I can type correctly, that is. There we go, and we can see, you know, whatever that image is that was on the device. Many of those images, you know, from this main part of the application here, all these images, to my knowledge, are being served in the clear. Now, maybe those wouldn't be sensitive, but if somebody that's between you and the server that you're getting this data from could see all of the posts that you were looking at, that might be a privacy issue, right? And this is why this is a bad idea, and this is why in the modern internet we encrypt all traffic. Whether we think it's important or not, we just put it everything in HTTPS, right? And we wrap TLS around all data, not just the stuff that we think is super sensitive. And so we can see lots of stuff in here that's being sent back and forth. There's just tons of clear text web traffic. This is more clear text web traffic than I've seen on any other mobile application. Sometimes a mobile app will get very non-sensitive resources over clear text. It's not good practice. I would always write that up if I was doing a pen test, but come on, guys. This is way too much data to be sending in the clear. So now let's give them some credit, guys. So now let's change our filter to TLS. So TLS is web traffic that is encrypted, right? It's when you go in your web browser and you type in HTTPS, that is going to create a TLS connection. It's going to be end-to-end encrypted between you and that web server. So this is going to be really secure, right? Well, let's find out. So first thing I want to do to kind of narrow my filter here in Wireshark is I'm actually going to find one of these client hellos. So that's like the initial communication when the client reaches out to the server. And I'm going to go down here into the TCP protocol, and I'm going to find where I can just filter this really easily. Okay, so here we say handshake type is client hello. I can actually go right click, apply as filter, selected, and it will select only the client hellos, which lets me get a really good view over here, because you can see it parses the SNI value, like the server name, right? For all of these TLS connections. So we see, Media Cloud, Picasso Static, a bunch of other servers that it is making secure connections to. But let's see if we can now do a man-in-the-middle attack on some of this TLS web traffic, right? So the way we're going to do that, like we said, is we're going to modify a little bit of this man-in-the-middle router setup. So here, like I said, it's just a shell script, guys. It's nothing crazy here. So what we're going to do is I'm going to simply uncomment one of these IP tables rules. So the way we read this IP tables rule is pretty simple, right? So we're running IP tables. It's in the NAT table, and we are going to have the interface be the bridge interface. So that's set in a variable way up top. And we're going to take any traffic that is destined for port 443. That's the most common TLS HTTPS port. It can be other ports, but we're just going to focus on that port for now. And any traffic that's meant to go out to that port, we're going to redirect it locally to port 8081. And then on 8081, we're going to run one of two different tools that are transparent TLS proxies, and we're going to try to man in the middle. We're going to try to force the phone to think that this evil man in the middle, is the Chinese server that it's supposed to be connecting to, and see if it will send us that traffic in an unencrypted format, or an encrypted. It's not unencrypted. It's encrypted for us, right? Because we're getting in the middle of that connection. So I'm going to save that IP tables rule, and then I'm going to run this again, and then Wireshark's going to yell at me because I take that interface down and then back up. So we do have to restart there, which I'm actually going to close out of our mobile app. And now what we're going to do is we need to set up a program called certmitm. So like I said, there's two tools that we can use here. One is man-in-the-middle proxy. This is a really cool tool, but the problem is that by default, it's always going to try to do the man-in-the-middle attack. Well, the cool thing is that there's this tool called certmitm, and what it will do is it will try to man-in-the-middle every connection to every server, but if the connection to one server, if that attack fails 3 times, it will stop trying to do the attack. And this is really important because if an app is going to go to server A, and then once it successfully gets information from server A, then it's going to go to server B. Well, if it keeps failing on A, it's never going to get to the code logic where it goes to server B that might be vulnerable, right? So This tool, really awesome tool. It will automatically do all of that, and it will only continue to man in the middle the things that are successful in that man in the middle attack. So I have this tool over here, and I've got my command all ready to go. So we're running certmitm, this Python tool, and we're listening on that port that we are redirecting to with our IP tables rule. So all traffic that's going outbound for 443 is going to get redirected locally to our server, and then our server will pass it on to the real server if it has successfully manned in the middle of the traffic. And then we just have some other options to be very verbose, and it's going to print all the data it gets out on the screen. So here we go. And we are now going to make sure that I am connected to the Wi-Fi, which I am because I killed the Wi-Fi for a second. And I'm now connected to the app. So let's view that over here again. And we can see, if we see red, that's bad, right? So that means that it was able to successfully do a man-in-the-middle attack on this domain. And so we see one so far, we're seeing more, and now we're starting to see the data that this app was actually sending over the air. So here we have some kind of API, and you can see that we're definitely seeing some kind of keys, some kind of identifiers. You know, here's an app key. I think this is actually like the real API key that's being used here for this account that we have. And as we can see, it keeps going. We are actually able to man in the middle quite a bit of TLS traffic. And the root cause here is that the client, whatever HTTP client is being used in this application, when it reaches out, it's just blindly trusting. It's not verifying that the server cert matches an expected, or it's not signed by a trusted CA that this app or that the phone's operating system trusts. It's just blindly accepting that, oh yeah, you say you're this server and you have this certificate, cool. I will connect to you. And that's why this man-in-the-middle attack is able to succeed. And both these vulnerabilities are real vulnerabilities that I have made money on in bug bounty programs in the past. And they're pretty simple to find, but you just have to know to look for them. And sometimes it just takes going back to Wireshark, going back to the basics, like actually looking at the packets that are being generated by a mobile app. Sometimes we're so focused on what's going on up at layer 7, up at the HTTP layer, that we kind of forget everything else that's going on the wire. And I will get off my soapbox. And thank you for watching this video. I hope you learned something, and I hope that maybe you have a new perspective on this application. Just because some app comes out and it's free and it seems like it's a good idea, it might not be. These vulnerabilities can exist in all sorts of applications and devices if they are not doing their job correctly. So thank you for watching this video. If you've watched to the end and you're not subscribed to this channel, please consider subscribing. It really helps me out, and I do lots of videos like this. And if you like the content, I think you'll like my other videos. Have a good day.